Hey math enthusiast, I'm here to continue the notes on the basics of trigonometry, reviewing the sine, cosine, and tangent functions. So in my first video we learned what sides of the triangle the functions represented. And we're using that phrase so, ka, toa to help us out. Now I want to see how I can use these functions to help me solve for missing pieces in a right triangle. So I want to start with 2b first because it's a little bit easier than a. Now, to start off with these problems, first thing you want to focus on is whichever angle they gave you besides the right angle. So if you recall, we cannot use the right angle. Alright, so I've labeled my angle. They give me that 27 degrees. Next thing I want to do is label all of my sides. Now in this case, you can label the hypotenuse if you want to, but we're not looking for that side and they don't give us that side, so I know right away I'm not going to be using the hypotenuse. The side across from the 27 degrees, x, is my opposite. That means the 25 next to the 27 degree angle is my adjacent. Now it's my job to determine what function I should use. So the two sides I'm focused on are obviously the opposite and the adjacent. Well, sine uses opposite, but it doesn't use adjacent. Cosine uses adjacent, but it doesn't use opposite. And tangent uses both of them. Okay, so now I know what function I'm going to use. So let's jot that down first. So after you write down your function, immediately following that, you are going to include the angle. So the angle I'm focused on is the 27 degrees. So remember, this is saying tangent of 27 degrees. Now, to continue my equation, the tangent of 27 degrees is equal to opposite over adjacent. So when I complete my equation, it's going to be opposite on top, which is x, over adjacent, which is 25. Okay, now I have to figure out how to solve for x in this case. Now in order to do that, it's important to understand that the tangent of 27 degrees is equal to some value. It's comparing the opposite side to the adjacent side. Now I know what this ratio is going to equal given that the angle is 27 degrees. And I can get that information from my calculator. And I would plug it in just how it's written up above. Tan, open parentheses, 27. Make sure your calculator is set in degrees, close parentheses, and hit equals, which gives me this decimal. So I'm going to go out 4 places. So it's going to be 0.5095. Now, if for some reason you're not getting that, double check to make sure your calculator is operating in degrees. Okay, so how does this help me? So to complete this equation, it might help to visualize this tangent of 27 degrees is really just this decimal, 0.5095, which is equal to x over 25. Now recall that my goal is to get x all by itself. So I want to get rid of that 25 in the denominator, essentially get rid of that fraction altogether. So what I'm going to do is I'm going to multiply this side of my equation by 25, or 25 over 1. That'll cancel out this 25 here. And I'm going to do the same thing on the other side. Multiply by 25. Which is going to give me 12.7. Now, the more accurate way to solve this equation would be to keep that tan of 27 degrees as is. So I would still follow the same steps, multiply this side by 25 or 25 over 1. They would cancel out, and what's going to happen is I'm going to multiply the left side by 25 as well. So what I'm plugging into the calculator is going to be 25 times tangent of 27 degrees. and you should get your final answer right around 12.7. So for future equations, I'm going to keep those trig functions written as is. I'm not going to change them to decimals. So if the if the angle I'm using is 51 degrees and the function I'm using is sine, I'm going to keep it written as sine of 51 degrees. I'm not going to change it to the decimal. So let's take a look at another example. So for example 2c, let's first point out the angle I'm focused on. So besides the right angle, they give me this angle, the 39. So from here, let's label the sides in my right triangle. So D is the hypotenuse. That one's easy. It's across from the right angle. 37 is the opposite because it's across from the 39-degree angle, which means C is my adjacent. Now, in this case, I am looking for two sides, and they only give me the one side. So to start, I'm going to have to use the opposite. And then you're going to have to decide which variable do you want to solve for next. In this case, we'll go in alphabetical order, so I'm going to start with C. Okay, so the next thing I need to figure out is what function am I using? So in this case, I obviously said I'm using the opposite side and the adjacent side. So if I go down my list, the one function that uses both opposite and adjacent is tangent again. So that's the first thing I'm going to jot down. Tangent of my angle, which is 39 degrees. So remember, this function gives you some decimal in the calculator, but I'm going to keep it as tangent of 35 degrees. Now I know the tangent function is equal to the ratio of the opposite side first, that'd be 37, over the adjacent side, which in this case is C. So I rewrote it just a little bit smaller, just so we have enough space to solve this. So this equation is a little different because x, or in this case my variable c, is in the denominator. So now I got to figure out how do I get c by itself when it's in the denominator. So first thing I'm going to do, and there are a couple different ways to do this algebraically, but first thing is I'm going to start off the same way I did before and multiply by the denominator. So I'm going to multiply this side by c, which is going to cancel out the variable in the denominator. It's going to leave me with 37 all by itself. But on the other side, I'm going to have to multiply the tangent of 39 degrees by c as well. So now I'm going to have the same exact thing, c times tangent of 39 degrees equals 37. So the last thing I want to do to get c by itself, remember the operation taking place in between c and the tangent of 39 degrees is multiplication. So the last thing I'm going to do is divide this whole left side by tangent of 39 degrees. Because remember, that is some decimal. It's some number that I can get from my calculator. What's going to happen? Tangent of 39 is going to cancel out. I'm going to be left just with c, and that was my goal initially. But what I do to one side of the equation, I must do to the other. So I'm going to have to divide 37 by tangent of 39 degrees. So c is going to equal whatever 37 divided by tangent of 39 is. Now, to plug this into your calculator, it might help if you figure out what the denominator is first. This way the order of operations doesn't get mixed up. So tangent of 39 degrees is equal to 0.8097. All right. So the more decimal places I'm going out, the more accurate it is. I'm actually going to round that up 0.098 instead. And my numerator is still 37. So essentially this is what I'm plugging into my calculator. and it looks like C is equal to 45.7. Now I need to go back to the beginning and solve for D. So to finish up this problem, I need the hypotenuse. Now, technically, I have an option. I could use the opposite end hypotenuse, or I could use the adjacent end hypotenuse. But since I rounded this answer, this 45.7, since that's not the exact length, I'm going to stick with the opposite. So I want to figure out what function uses opposite and hypotenuse. So I'll go to my list up top. It's definitely not tangent. It's not cosine because that uses adjacent and hypotenuse. It looks like I'm using sine. Sine uses opposite and hypotenuse. So I'll jot that down first. So I'm using the sine function. I'm taking the sine of the angle I'm focused on, that 39 degrees, and I'm going to set it equal to the ratio of the opposite over the hypotenuse. So the opposite is 37 over the hypotenuse, which is D. Now, this equation should look very similar to the equation we had last time. So if you remember, it was tangent of 39 degrees equals 37 over C. So the only thing that's changed is the trig function I'm using. I went from sine to tangent, and the variable from D to C. So let's recall how we solved that equation and use that same method to solve for D. So the first thing I want to do is get that variable out of the denominator. So I multiplied both sides by D. Now I have 37 all by itself. And I did the same on the left-hand side. So I have D times sine of 39 degrees. Remember, that's some decimal I can get from my calculator. And it equals 37. The last thing I'm going to do to get D all by itself is the inverse operation. So it's D times sine of 39 degrees. I'm going to divide by sine of 39 degrees. Those two are going to cancel out completely, and I'm just going to be left with my variable on the left-hand side. But I have to continue to do that to the right-hand side. So now I have 37 divided by sine of 39 degrees. So this is what I need to plug into my calculator. Now we could do the same thing we did last time, which was to change that to a decimal. Sine of 39 degrees is going to be equal to 0.6018, and my numerator still is 37. Now, before I hit enter on the calculator, my expectations are that D is going to be greater than 37 and 45.7 because D is the hypotenuse in this triangle. So let's see what we get. So I end up with 61.5, which is indeed greater than my other two sides. Now, a quick thing I wanted to note, when solving this equation, we're always going to follow the same steps if the variable happens to be in the denominator. So you're always going to multiply by the variable, and then you're always going to divide by the trig function like we did here on the left. So if you remember, this is what we had initially, and then I ended up with D equals 37 over sine of 39. So in this case, the 37 stayed exactly where it was. The only two items that switched places were the sine of 39 and my variable in the denominator. So if I just switch them automatically, that will bring me to my final step of D, or the variable, equal to the opposite over your trig function. So if I had another equation, let's say they gave you tan of 53 equals 10 over x, Well, in this case, since the variable is in the denominator, what I can do to solve for x real quick is switch those two. So I know that x would be equal to 10 divided by tangent of 53 degrees. So if the variable's in the denominator, it will always follow those same steps algebraically, which means you'll always end up with a setup like this as your final step. So now let's use that information to help us take a look at A. So the first thing I notice is the angle they give us besides the right angle is 58 degrees. So I'm going to use that to help me label my three sides. Conveniently, H is the hypotenuse across from the right angle. G is your opposite side across from the angle I'm focused on, the 58 degrees, which makes this 3 radical 11 your adjacent side. Now that is the only side we're given. So I'm going to have to use the adjacent side. So that tells me right away that I'm either going to use the cosine function or the tangent function, depending on what other side I want to solve for. So let's start off the same way we did before, and I'll go in alphabetical order. So let's go after G first. So now I'm looking to solve for the opposite side, and I'm using the adjacent side. We already narrowed it down to cosine or tangent, but in this case, since I'm using opposite and adjacent, I'm going to be using the tangent function again. So let's jot that down. Tangent function, the angle I'm using is the 58 degrees, and the tangent function is opposite first over adjacent. So my opposite is G, it's my variable, over the adjacent side, which is 3 radical 11. So once I have my equation set up, now I have to get my variable all by itself. So let's get rid of that 3 radical 11 in the denominator. So I'm going to multiply the right-hand side by 3 radical 11 over 1. So what that's going to do for me is those two are going to cancel out, and I'm going to be left with just G on the right-hand side. But we also have to multiply the left-hand side by 3 radical 11. So now I know that G is going to be equal to whatever 3 radical 11 times tangent of 58 degrees is. So there's a lot going on there. It might help if we change each of these into decimals first, just to ensure that we don't mix up our order of operations. So my 3 radical 11 is going to come out to be 9.95, and my tangent of 58 is going to be 1.6. Now when I multiply those two together, I end up with 15.92, but I'm just going to leave it as 15.9. So now I need to go back and solve for the hypotenuse. Now once again, even though I solved for the opposite side, I'm still going to use the adjacent to help me solve for the hypotenuse. So I need to go to my list of functions and figure out what function uses both adjacent and hypotenuse. And that appears to be the cosine function, the last function that we have not used yet. So that's what I'm going to jot down first. It's going to be cosine, that angle that I'm focused on, that 58 degrees, and it's going to be equal to adjacent first, which is that 3 radical 11, over my hypotenuse, which is H. So now you can see that we have that set up where the variable is in the denominator. So earlier I showed you guys the shortcut on how to solve for the variable when it's in the denominator. Essentially what I'm going to do is I'm going to take that variable, H, and it's going to switch places with cosine 58. This will save me all those steps algebraically. I know that the final answer is going to be H equal to 3 radical 11 over cosine 58. Now, once again, it might be a little bit easier to change both of these into decimals. I already know that 3 radical 11 is going to be equal to 9.95, and cosine 58 is equal to 0.5299. Now, once again, before I plug this into the calculator, I'm going to expect my hypotenuse to be greater than my other two sides. So it should be greater than the 3 radical 11, which is that 9.95, and it should be greater than 15.9. And it's equal to 18.8.